How do you run macOS CI/CD at Kubernetes scale without babysitting fleets of Mac minis? In this episode of KubeFM, we sit down with Vitalii, a platform engineer at Agoda, to unpack how his team integrated native macOS workloads with Kubernetes. We dig into macOS VZ Kubelet, built on virtual kubelet, that registers macOS hosts as nodes and spins macOS VMs via Apple's virtualization framework, including hybrid runtime pods, VM plus sidecar containers, an OCI-backed VM image format, 55 to 60 gigabytes, with gzip compression, layered cow disks, and digest validation for integrity. We also covered networking constraints, such as direct NIC access and Apple entitlements, kubectl exec over SSH, MDM-based host lifecycle, and what to watch if you're considering open sourcing similar infra. Stay tuned for lessons learned, trade-offs, and whether you should build or buy for Apple infrastructure at scale. Special thanks to TestCube for sponsoring today's episode. Need to run tests in air-gapped environments? TestCube works completely offline with your private registries and restricted infrastructure. Whether you're in government, healthcare, or finance, you can orchestrate all your testing tools, performance, API, and browser tests without any external dependencies. Certificate-based auth, private NPM registries, enterprise OAuth, it's all supported. Your compliance requirements finally met. Learn more at testcube.io. Now, let's get into the episode. Vitalii, welcome to KubeFM. What 3 emerging Kubernetes tools are you keeping an eye on?
Oh, that's an interesting question because there's so many. A few that comes to my mind. So one of them is Envoy Gateway. It's basically like L7 routing implementation. The reason for that is because we have kind of similar problem at my workplace currently. We do, however, implement our own solution, but this one in particular is basically like a lot where we get some inspiration from. So in that sense, it's a quite interesting one. Another one is not really an emergency NCF tool yet, but I hope it will get there soon. It's basically another project that one of my teammates works on, and he plans to open source it. It's called etcd operator. So there's not many etcd operators available right now publicly. Basically, it just helps you set up, manage, provision, deploy, and backup your etcd database for Kubernetes. And yeah, hopefully that's gonna be available soon with an article similar to mine. The third one, if I remember correctly, it was called something like OpenYurt. It's basically like lets you deploy your nodes to multiple region or something like that. To me, it was quite interesting because you don't see solutions like this quite often in Kubernetes. So yeah.
Fantastic. Now, Vitalii, for people who don't know you, can you just tell us about who you are and where you work?
Yeah, so my name is Vitalii. I'm a software engineer, mostly focusing on platform engineering, currently working at Agoda. It's a booking holdings company. Basically, we're a website that lets you book hotels, flights, activities, and we're mostly popular in Asia. So I'm in particular mostly focused on platform engineering, and my current team is basically our own private cloud platform and infrastructure on Kubernetes.
Very good. And how did you get into cloud native? Tell us about your journey.
Yeah, so well, basically, I can just join the team that was already implementing and bootstrapping our own infrastructure on Kubernetes. However, before that, I had an introduction into the whole cloud native and Kubernetes in particular when I was working on mobile infrastructure and doing CI/CD for mobile projects like iOS and Android. Because we had like a lot of solutions running on Kubernetes, and that's why I had to first learn what Kubernetes is, how it works, all the cloud native tools around it, and so on.
And how do you keep updated with all the changes going on in the Kubernetes and cloud native ecosystem?
Well, that's a tough question because I don't have any particular source in mind. Usually it's like, for example, following conferences like KubeCon, I can just like look around some titles, maybe something interesting popping up there. Definitely, unfortunately, don't have time to watch everything. And then maybe like from my colleagues that also into cloud native stuff, you can hear like a lot of things going on. Maybe social media, something like Reddit, news articles, and so on. Yeah, definitely not a single like specific source, but a lot of places.
Okay. And if you could go back in time and share one career tip with your younger self, what would it be?
Well, in terms of career, I probably wouldn't change anything. However, one tip that comes to my mind is be open to learning new things outside of the box of your technologies. If you're like a mobile engineer, like look outside into like, I don't know, some other things like Kubernetes or web development and so on. Yeah, just basically be open to learn new things.
As part of our monthly content discovery, we found an article that you wrote titled How We Integrated Native macOS Workloads with Kubernetes. So we'll dig into this topic a little bit more with the following questions. Many companies struggle with managing Apple infrastructure for iOS development at scale. What was the situation at Agoda that led you to completely rethink your approach to macOS CI/CD infrastructure?
So when I initially joined Agoda, they were already using Kubernetes for iOS CI/CD, basically where they were running a lot of tests for the iOS application at a very huge scale. They had like around 20,000 tests running there, and the pipeline was like taking hours. And basically, there were like a lot of machines. They had to utilize like around 200 Mac Minis for that, and the reason they went into Kubernetes because it's like basically a scheduler that lets you like run the jobs at scale, right? However, there were like a lot of problems, and basically that's what we had to solve. And the article that we're going to discuss today is basically one of the solutions that we did in the end.
The introduction of Apple Silicon seems to have been a turning point. How did this hardware transition expose the limitations of your existing virtualization approach?
Yep. So like I mentioned, we were already running it on Kubernetes. However, the way we were doing macOS on Kubernetes was basically we took Mac Minis and we installed regular Linux on them. And with regular Linux, we were just running a normal kubelet, normal like certificates, everything that you would normally provision a node in Kubernetes, and then we would connect it to the Kubernetes cluster. So it would appear as a regular node. Can potentially run any like regular workloads. However, our goal was to run macOS. And so what we did is having this specific Linux node on Mac Mini, we would then run a pod that would run Camel, which is basically like virtualization software. And with Camel, we would just bootstrap a macOS itself by using custom open source bootloaders that were available at the time. And that basically is the extra layers that we had to do in order to run macOS on Kubernetes. So there's quite a lot of work, a lot of stability issues, and especially like performance problems. Yeah, so basically then we were running that on our primarily Intel Mac Minis, and eventually Apple moved to their new processors, M chips, called M chips, yeah. Those were ARM, but they were not just regular ARM architecture. It was like ARM architecture with a few extra Apple instructions on top of it. The problem with that was that it was a little bit tricky to run Linux at first until the project called Asahi Linux appeared. So now you can actually successfully run Linux on those machines. And when I was doing my first POC, I was able to successfully like provision a node into Kubernetes using the new Mac Mini with M chip, using Asahi kernel. However, the problem comes with the next steps when we were running Camel with macOS itself, right? So as I mentioned before, we were using open source bootloader, and there's like a lot of work from open source done in that case. However, it's primarily for x64 architecture, and it does not support ARM and probably will not support anytime soon due to a lot of like specifics of these Apple instructions of their own ARM chip. And so basically, at the time, even though I was able to provision a node itself, I wasn't really able to run macOS workload on that machine. So that was not very helpful for us. And that's basically why we had to look into other potential solutions that didn't require us to install Linux on the machine itself.
You mentioned that your previous Kubernetes solution only handled part of your infrastructure. Can you explain what was working and what wasn't before you developed the macOS versus Kubelet?
Yep. So while we were able to successfully run Kubernetes on those Mac machines and then basically run macOS workloads using Camo, the performance was not great. For example, let's take like a build process on iOS, right, for iOS apps. It's a very CPU-heavy process, and when we run those layers of abstractions, we were losing like 100+% of time on building those things. So essentially, the only things that we were able to use the Kubernetes scale solution was for running UI tests, where we just basically spin up like a simulator on iOS, and it just like clicks around application just to run like a specific set of tests to make sure everything works. Yeah, it was still like slower than usual. However, it was much easier to do that than, let's say, maintain like 100 plus Mac Minis and running some bash scripts on them. Like, because we were running a VM, you can just like do something, kill VM, restart, and you basically have like a fresh OS with everything you need to pre-install. On the other hand, everything that required like build system or everything that was CPU heavy, we had to run on Mac machines directly outside of Kubernetes without any virtualization. We just had like a Mac Mini running, like maintained by bash scripts, and we were scheduling a job there. Not a perfect solution, however, performance-wise, that was the only thing that we could do at the time.
The core innovation here is running a Kubernetes kubelet directly on macOS. For those familiar with Kubernetes but not Apple infrastructure, can you explain what macOS VZ Kubelet actually does?
Yeah, so basically macOS VZ Kubelet is built on top of a Virtual Kubelet, which is another cloud-native project that implements a communication layer to Kubernetes and provides you like a Golang API. It helps you register node with leases to Kubernetes cluster, and it basically works with API requests, and you can just handle them coming from Kubernetes. For example, you register your node, Kubernetes schedules some job or pod on it, and you receive like an API call from Kubernetes saying, hey, like this pod appeared in your node, this is a specification of the pod, like do what you want with it. After that, you basically need to build your own layer, doing something with it. And in macOS VZ Kubelet case, we basically built a layer using virtualization framework, which basically spawned in macOS VMs coming from those pods from Kubernetes.
One fascinating feature is hybrid runtime pods when you can run macOS VMs alongside Docker containers. What practical use cases does this enable?
Yep. So basically, when we were building the solution, we were building for multiple specific case in mind in our company in particular. So one of those was having an ability to run some kind of sidecar container alongside your macOS workload. For example, in our case, we are running GitLab controller on Kubernetes that schedules jobs from GitLab CI/CD to Kubernetes. And the way it works, they basically set up multiple containers. One container is for building, like basically doing everything that the job wants you to do. And sidecar containers, they're using to fetch a Git repo and like some kind of helpful scripts, like preparation and so on. And they just basically mount the folder, the directory from one container to another. And that's how they process, right? So that's one of the cases. Another case, for example, you want to have some kind of scripts monitoring your VM or basically anything where you need a sidecar container. So that was our use case and why we needed an implementation of like a Docker runtime or similar.
Managing VM images efficiently is crucial at scale. You developed a custom OCI format for macOS VMs. Can you walk us through how this works and why it was necessary?
So on ground level of schemes, it kind of like sounds easy. You just have like a macOS disk image. You just need to package it and throw it to OCI. In reality, it was not as easy. I had to look into, for example, macOS disk image is quite huge. It's like around 60 gigabytes. So just like you install macOS, you install Xcode or whatever like you need for your macOS workloads, it's already 60 gigabytes. It's quite a lot. So one of the things I had to look into when developing custom OCI format is basically reducing the size. And in our case, it was just like using some kind of algorithm like a gzip to wrap it up and have a smaller size. So that was helpful. Another thing was basically, okay, we need some kind of format of versioning format, right? Whether like the specific container of specific version run specific things. That's what we did as well. Yeah, we used mostly like Oras. It's another quite good open source tools when you need to work with OCI images. And they have a good library that you can just import and go and just create your own OCI formats, which was quite helpful.
With VM images averaging 55 gigabytes, storage efficiency must be critical. How do you handle multiple VMs sharing resources on the same host?
Yeah, so like I mentioned before, we do this GZP approach to reduce the size of the disk images. However, you're right. If you try to download it, multiple like images on the same host, it takes quite a lot of space. On the other hand, also when you spin up a VM, right, on your pod, you cannot just use one disk image, because if you change something, then another VM might be affected as well. This is where we just basically implemented a layering system where we just create a layer on top of existing disk image for a specific VM. And then when VM is done with its own job, we just delete this layer completely, and there's no change to the initial disk image that we have in cache. So we can basically just able to reuse one cache image for all of the VMs that will be spawned into the machine.
Image integrity is crucial for CI/CD. Can you explain your digest validation system and how it ensures VMs are running the correct images?
Yep, so another case that we had to look into, for example, what if a cache of the disk image gets corrupted? For example, maybe somebody accidentally changed it, or maybe we didn't download like a full disk image correctly from the OCI. This is basically where we did another extra implementation of calculating the digest and store it in a separate digest file for the disk image. And basically every time we just validating that nothing changed. Recalculating the digest for a 60 gigabyte image every time would be quite expensive. So the approach that we did was basically we have a digest file and we have a disk file. If the digest file is newer than the disk file, then everything is okay by default. If a disk image for some reason is newer than the digest files, then we need to recalculate the digest and make sure it didn't change. Otherwise, we have to invalidate our cache and download the image again, which is quite costly time-wise.
Networking in Apple's virtualization framework has unique constraints. What challenges did you face and how did you solve them?
Yeah, networking, I would say, is definitely the most painful part of this whole implementation. While Apple has this framework called VMNet, which is actually quite extensive, it's C++ based, I think, if I remember correctly. They don't really give you access to that in the virtualization framework. So virtualization framework uses VMNet underneath, but when you use the virtualization framework itself, you're not able to use VMNet directly. So you have to use the API that they provided for you. And there's not much room over there. So unfortunately, we cannot like set up some kind of virtual network on the machine and then provide it to the VM. Yeah, so that's one of the downsides of using virtualization framework. So what we did essentially in our case, we are using the direct network approach, where we just basically give direct network card access to the VM. And VM just uses an IP address from one of our VLANs that we set it up on the Mac machine itself.
The kubectl exec implementation using SSH is interesting. How does this provide seamless interaction with macOS VMs through standard Kubernetes tooling?
Yeah, so one of another things that we were looking into, we really wanted to have like a native pod level access to the container underneath, which is VM basically. And kubectl exec is perfect for that. For example, the GitLab operator that I mentioned before uses exactly kubectl exec to get into the file system of the containers of VMs. And in our case, virtualization framework, unfortunately, once again, doesn't provide any helpful tooling for that. So what we did is we implemented like an under the hood of macOS VZ Kubelet, we run an SSH connection to the VM itself. So every time you do kubectl exec to macOS VM in pod, what happens underneath, we just SSH into that VM, and you're just able to use kubectl exec as normally. Like to you, it will look like normal kubectl exec with no changes at all. But underneath, it's SSH connection, yeah.
You mentioned needing Apple's approval for certain networking capabilities. What administrative and signing challenges come with developing this kind of infrastructure tool for macOS?
Yeah, so that was one of the, I would say, smaller challenges, but Apple by default does not give you a direct network card access to virtualization framework. I think it's probably related to some security things, so you don't accidentally deploy to production some tools that might hack people's network cards. So essentially what we had to do is on our Apple developer account, we just sent a request to Apple saying, hey, we have this and this requirement. We want to use direct network card access in our virtualization framework application. They just asked us, what do you need it for? Like, what this tool will do. So we explained, we do this and this with VMs, and they said, okay. And then basically we get a capability that we need to enable on our provisioning profile in Apple Developer Portal. So anybody who's familiar with iOS provision system will understand. It's quite complicated, but essentially what we have to do every time we build this binary of macOS VZ Kubelet, we have to sign it with Apple provisioning profile and developer certificates. And only after that it will work, because by default, macOS will kill the binary that tries to access something that you are not allowed to, and you didn't sign properly.
Managing the underlying Mac host is beyond Kubernetes scope. How do you handle provisioning and lifecycle management of the physical Mac minis in your data centers?
Yeah, so that's basically like similar to what we do with other like nodes in our company. We have a compute system that is related to like OS patching, provisioning, but in macOS case, we had to go a little bit step further. And there's like a lot of MDM solutions, basically management solutions for Apple that are officially supported by macOS. The one we use, I think, called Jump. It's essentially just like a tool that lets you set up your machines in specific like groups, and then say, hey, like they need to be OS updated by this time. You need to maintain this and this. As long as you don't try to install many things in there, it's quite easy to manage macOS machines. But as soon as you try to like, okay, I need this specific dev environment with this specific like tools, then it becomes like quite hard to manage. But in our case, yeah, it's just like OS patching, making sure like all the permissions are correct, and automatic provisioning of the machines.
Now that you've open sourced macOS VZ Kubelet, what should teams know before adopting it for their own Apple infrastructure?
I would say like with absolutely anything with development world it's case by case. You need to investigate whether something is good for you budget wise, or whether like you have knowledge for that. Because while we open source like a good part of our specific solution, you still need to maintain the infrastructure, right? You need to set it up somehow. You need to provision those Mac machines. You need to have like a Kubernetes infrastructure. So if companies that have already their own Kubernetes infrastructure want to adopt this solution, I think it's perfect for them. Otherwise, if you're not familiar with Kubernetes and you didn't run it at all, it might be a little bit tricky to set up something like this.
Looking back at this journey from office server rooms to data center scale Kubernetes-native Apple infrastructure, what key lessons would you share with other teams facing similar challenges?
So I think, well, with Apple, it's like Apple infrastructure is quite a huge problem on the market. There's like a lot of solutions, a lot of the companies trying to sell their own things. If you don't really have a huge infrastructure, like let's say you just like have a small project, you have a small pipeline, and you can like utilize like 2-3 Mac minis, you probably don't need to build anything custom or pay like a lot of money for any kind of solution. If you have a huge infrastructure and you serve a lot of hours of macOS workloads, that's probably where you just need to start thinking which solution might be better for you, and where you just have to sit like and calculate whether maintain your own solution or paying some company for the already out of the box solution is a better approach. Yeah.
Having done all this, what's next for you?
Well, primarily now I'm working mostly on Kubernetes operators and compute provisioning in my company. Other than that, I think as soon as I will start getting bored, I will look into some new things for developers to do. You know, like there's a big AI craze right now. Like maybe something interesting will emerge there.
Fantastic.
Yeah.
And if people want to get in touch with you, what's the best way to do that?
I would say LinkedIn is quite easy. I look at it at least once a week. So if somebody has any questions, feel free to reach out to me. I will try to answer my best.
Much appreciated. Thank you so much for sharing your time and knowledge with us today. Look forward to reading more blogs of yours in the future. Take care.
Cool.